Okay, if you watched my first video, you heard all my yip-yapping about everything having a certain science to it. I suppose we all know that. And there's always progress. So here it is. Made it a little better, a little more progress. And instead of one, I have got two transistors. 1, 2. The output of one into the base of the other magnifies it. Plus the sensitivity of these things. I put a resistor there to ground the base on this, so it doesn't have it doesn't get all sensitive to my presence. And here we go. This one will be a lot simpler because I did all my long drawn yip-yapping on the first one about all of this stuff. So this is just a continuation to simply show that you fiddle around with these things long enough, they all got their own personalities, they all got their own way of doing things, and they all got their own math, they all got their own, all that stuff. Yes, sirree, Baba. So this is a little more visible, more powerful, more more oomph. And who knows, one of these will probably go outside and send a signal. So let's see, here we go. See that? All right. Maxed out, right about there. Right about there is maxed out. Now, check this out. I'll put it twice as far. Yeah. All the way there. Maybe a little too far, but we'll see. Remember the big kahuna? Let's see. Put it right here. Okay, here we go. Oh my goodness. The radar has got to, these antennas got to be in line. How about that? See, and if you guide this, find a way to guide because remember I said the waves just take off every which way? A lot of them wanders off, but they have a wave guide, if you will. If you get a wave guide, it will direct it, and you can just keep on going. You fiddle with this thing long enough, and it evolves. And describing it is another thing. The language you use. And the last time I said a few things that could have said it differently. As I was saying that electromagnetic energy moves, among in other ways, it moves through by electromagnetic waves. And the waves are not energy. The waves carry energy. And the wave, for instance, here starts, electrons does not carry energy, waves do through empty space. But it's not exactly empty space. Empty space is not exactly empty. In the old days, when they first came up with these things, they use physical things that waves need a medium to move through. By medium, they meant physical, like water or air, or because it had molecules or whatever. But you see, electromagnetic waves do not move through empty space. There's no such thing as empty space. It has a medium. You see, it's plain and obvious. That's how Maxwell, came up and calculated the speed of light. It's 1 over the square root of permittivity and permeability of so-called empty space. So you see there's that oscillation. The permittivity refers to the electric capacitance part of it, and permittivity is the magnetic aspect of the wave, which is, you see, it's the inductive aspect of it and capacitance aspect of it. The current and voltage always go together. So you see, it will not go any faster than the so-called this permittivity and permittivity of so-called empty space. It dictates. Anyway, that carries the energy, but that in itself is not energy. The wave does not actually move. The wave just oscillates. Like water does not move, wave does not move. Wave is just a shape. Like water waves does not move. Wave is a shape in the way you move. Like you can move, like circle is not movement, it's the way you move in a circle. You move in a straight line, you move in a waves. But those straight line and waves and circles, they are not movement. They are a shape, the form of in which you move, the style you're moving. You see, so these things, it's never made clear. Wave does not move. Wave is a shape. Energy moves. Energy moves in the form of a wave. You see, so the fields oscillate, the waves move. The energy moves, the fields oscillate in a form we see as a wave. Energy moves. Waves move from here, or a wave, empty space, wave is gone. Then electrons in the conductors, because antenna is a conductor. Wires, these are all a guide. They are kind of like a wave guide. But the waves are always there. The waves are even in the circuits, because energy does not move in open field. It does not move through wires. In fact, as far as the energy is concerned, the wires are loads. The wires are loads. It goes into the wires too as a load. Out into the field. See? So if you look at Poynting vector, you will see that energy actually does not go in the direction of current, does not go in the direction of, which implies current is what? Implies charge, direction of electric field, and then magnetic field, which is perpendicular to that. It does not move in that direction either. It moves orthogonal to both of them. So energy does not move in the direction of current or magnetic field. See? So therefore energy moves out of the source, and then into the field, and from the field into the wires, and the rest of it is neither created nor destroyed. That's how they said it. Like I said, I don't want to go through this thing over again twice. Don't want to bore anybody. I said it all in the first video. So the point of this is, there you have it. It's a little more powerful, and I think if I take this out farther away and shoot that million volts, it will still light it up. Until next time, bye-bye.